While heat decarbonization is an area of great uncertainty, there are some commonalities across our future energy scenarios, and one of these is the increasing electrification of heat. This means that the amount of energy needed to meet periods of high peak demand will impact things such as the amount of network that needs to be built or the amount of generation that will be needed. This impacts consumer costs and leads to specific challenges for the operation of the energy system. At the moment, majority of homes in Great Britain use natural gas with their heating. In winter 2018-19, the gas network transported almost 4 times as much energy as the electricity system. And 22 million homes currently use gas boilers for their heating compared to 3 million homes that use electric heating. The physical characteristics of the gas network are quite different from the electricity network. Unlike the electricity network, the pipes of the gas network actually can store a huge amount of energy, and we call this the line pack. As an illustration of the size of the line pack, the gas stored in the line pack in Great Britain is enough to fill Wembley Stadium 300 times over. If more gas is taken out of the system than is put in, the line pack will drop slightly and the pressures will drop a little, and vice versa. In both cases, the line pack is used to help manage any imbalance between demand and supply, and pressure changes slowly. In addition, the users of the gas transmission system can tolerate some change across pressure range throughout the day. In contrast, on the electricity network, demand and supply need to be balanced on a real-time basis, and much less electricity can be stored on the network using technologies like batteries or pumped storage. If demand and supply are not equal, slight imbalances can lead to rapid changes in frequency, and the network can become very unstable very quickly. In addition, users of the electricity transmission system require frequencies to be kept within a tightly defined range. The consequences of these two different systems are that imbalances in electricity demand and supply needs to be managed carefully to keep them small and resolved within seconds. But relatively large imbalances in gas supply and demand can be managed over hours, so long as they are brought back into balance by the end of the day. As in all of our decarbonized scenarios in FES 2019, the use of gas for domestic heat reduces significantly, and there is greater electrification of heat, with technologies like electric and hybrid heat pumps growing from a couple of 100,000 today to potentially 70 million in 2050. As the amount of electric heating grows, we can therefore see that being able to move demand across the day becomes more important. This helps to manage the electricity network and helps to manage periods of high demand when demand risks outstripping supply. There's a huge number of questions that we need to drill into in thinking about how to decarbonize heating and how to manage peak heat in the future. In FES 2019, we looked at development in many different low-carbon technologies, including hydrogen, district heating, and many others. Today, however, we want to restrict our discussions to look into challenges of managing peak heat on the electricity system, focusing on residential heating.